All right, college algebra, lesson 6.5, part 2. So now we know what a rational function looks like, how to find its vertical, horizontal, and slant asymptotes. So we're going to step aside from graphing them and look at solving them algebraically. We can still use graphing to help us solve a little bit. If you have your calculator handy, that would be good. But we're going to step aside from that and do algebraically first. So the first thing you want to do when you're solving algebraically is clear those fractions. We don't want to be dealing with fractions on both sides of the equation. And the difference in these is there will be an equal sign without a y equals. It's just going to have x's, and we're solving for x. So to get rid of the fractions, you multiply both sides of the equation by the least common denominator. And then you're going to be left with an equation to solve. So you're going to use your Algebra 1, Algebra 2 skills to solve that equation. The one thing to be very careful of is make sure you check your solution, because these will end up with those extraneous solutions sometimes that you need to check for. So let's get started with the problem here. Looks kind of scary. Be a little bit careful because this book says solve it for x. This part is not part of the equation. This here is my equation that I'm solving. So just don't let that part confuse you. So here's my equation. There's my equal sign. And I've got all this stuff going on. First thing you want to do is find the common denominator. So what do I have on the bottom? X minus 1. Not too hard of a common denominator this time. So what I want to do is multiply the entire left-hand side of the equation by x minus 1. I'm just going to put this little bracket here. And the entire right side of the equation by x minus 1. What that's going to do for me is when I go to multiply it here, it's going to cancel out. But I still have to have this term with it. So the first term here is going to be x squared times x minus 1 plus, when I multiply this one, the x minus 1s are going to cancel, so I'm just going to have an x. Then I have my equal sign, x times x minus 1 plus, and over here, this fraction, they're going to cancel again, so I just get x to the third. So it looks like I've got lots of x's going on. Let's go ahead and do a little bit of distributing here and clean this thing up as much as we can. So distribute here. I'm going to change my color. So we're distributing. We're going to get x to the third minus x squared plus x equals x squared minus x plus x to the third. So that's just taking care of those parentheses there. Now I like to start with the highest power. So I've got an x to the third on both sides. I'm going to subtract x to the third, and guess what? It's gone. All right, now I have x squared on both sides. This one's negative, so I'm going to add it over here. And now I have x equals 2x squared minus x. Whenever we have an x squared, I like to get everything on one side, so we're going to move this x over here as well. So now I have 0 equals 2x squared minus 2x. Here we go. Next step, solve this. So to solve it, there's a couple different things we could do, but I see that they both have some stuff in common, so I'm going to factor out a 2x out of both terms. So if I take 2x out of this, I'm left with x. And if I divide 2x out of this, I'm still left with a 1. So don't forget to put that 1 placeholder. Now I have my zero product property. I have two things that multiply to be 0. So either 2x equals 0, which means the answer is x equals 0, or x minus 1 equals 0, which means the answer is x equals 1. Now, I'm not sure that I'm done yet, so don't forget to go back and check those solutions. So we're going to go all the way back up here to the original problem. 0 is pretty simple here. If I plug in a 0 plus 0 over negative 1, that's 0, equals 0 plus 0 over negative 1, that's still 0. So 0 does work. There we go. Let's plug in a 1. What happens when we plug in a 1? Uh-oh, what happens right here? We're dividing by 0, so the x equals 1 is an extraneous solution. It does not work because I divided by 0 when I plugged it in. So that's really what you're looking out for. If you want to make sure you're absolutely correct and it was another number, you could use your calculator and type these in and just confirm that the left side equals the right side. For now, our answer is 0. All right, the next few slides are just the publisher going through solving this. So if you want to look at their work, you can do that as well. That's their solution, and then this is them showing their work and checking their answers. Let's go on to another problem. This one is an application. So we have monthly sales. Keep in mind, this is in thousands of dollars for Yang products are related to monthly advertising expenses in thousands of dollars according to this function. So here's my function. Determine the amount of money that must be spent on advertising to generate $100,000 in sales. So remember, sales was Y, but it's in thousands. So what I want is my Y to equal 100,000. So what they're asking for is when will Y equal 100? So to solve this algebraically, I just plug in a 100 right here for Y. And then we need to solve this problem. So just like the last one, find your common denominator. Well, I only have one denominator. It's 15 plus x. So I'm going to multiply this side by 15 plus x. And the good news is it will cancel. And I'm going to multiply this side by 15 plus x. And I have to actually do that. So 100 times 15 plus 100x equals 300x. And then we just finished solving our equation. So get my x's on one side. This one's just linear. I'm going to jump down here. So 1500 equals 200x. And then you just take your calculator and divide by 200. 1500 divided by 200 is 7.5. Now, what does that mean in the context of this problem? It means my expenses in thousands would be 7,500. 7.5 thousand is 7,500. And that would be dollars spent on advertising to get 100,000 in sales. That's how that works algebraically. Now, I could also solve the same problem graphically. So let me show you. Here is the book's work to solve that to get 7.5 and their written answer. And then they also showed you could solve it graphically. Just put this in your calculator. Don't forget those parentheses when you type that in. And put 100 in. Find where they intersect. So you're using second, trace the intersect. All right. Last part of this lesson is on inverse variation. So now that we've looked at rational functions as graphs and solving them, we can solve inversely proportional relationships. One example of this is like the faster you drive, the less time it takes to get where you're going. So we talked about these one other time, but they fit in this lesson because they are rational functions. They can also be inversely proportional with the nth power of x. So that x term on the bottom could be a polynomial. It could have a different power other than to the first power. So let's do an example. This one's going to sound kind of familiar, but the illumination produced by a light varies inversely. So I would just start with y equals, because I don't really have any variables here, as the square of the distance. So k over, and then it says the square of the distance. So that's d squared, not just d. It's got a power there. So that basically gives me my formula. Whenever you have these varies inversely or directly or jointly or whatever, you're going to want to start with writing your formula. So y is going to be my illumination, d is the distance. Now they're going to give me some numbers. If the illumination 30 feet, that's distance, from a light source is 60, that's my y. So let's take that next sentence and put d equals 30 and y equals 60. So I'm going to put a 60 in for y and a 30 in for d, and don't forget that it's squared there. So let's solve that. 30 squared times 60 is 54,000. So k equals 54,000. Now, that's sentence 2. Now we're going to go to sentence 3. It says, what is the illumination 20 feet from a light source? Well, now I have the formula with a 54,000 right here. And they asked me, what is it if it's 20 feet away? So I can plug in a 20 in, the distance spot, 20 squared. So what is 54,000 divided by 20 squared? And the answer is 135. My units on that would be candelas, just like up here where I had my Y value was in candelas. And that concludes our lesson 6.5. Your assignments are posted on Google Classroom.